Okay guys, in this demo tutorial here, I am going to use this network diagram, and this configuration is about using BGP weight and local preference to influence BGP routes from one AS to another. So here's the network diagram. Basically, I have 5 routers set up here. Router 1 and router 2 is in its own BGP AS of 65100, and then for router 1, router 2, I've added their loopback addresses and then their direct connected network into the BGP routing process. We can take a look here. Show run pipe begin router. So basically, router BGP here, and I have the neighbor set up. Router 1 is forming a neighbor with router 2 and router 3, as you can see here. And also the loopback address is advertised into the BGP routing table, and so is the directly connected network between R1 and R2. All right, and then so that's R1. R2 is pretty much the same. If you take a look here, it's in its 65100 AS neighbor with R1 and R4 in this situation. R1 and R4, and advertising the loopback address and also the direct connected link between R2 and R1. All right, and then similarly, R3 is going to be the same setup. It has its own AS 65200 along with R4 and R5 in the same 65200 AS, advertising their loopback addresses into the routing process here, into the BGP network. There you go, and then advertising the directly connected links, which is 34 and 35, and it's got a neighbor with R1, R4, and R5. So here's R3 has a neighbor with R1, R4 forming its IBGP neighbor, and R3 to R5 forming its IBGP neighbor. So let's go ahead and take a look at the routing table for R3 and see how we are learning the loopback of R1. So R1's loopback is 1.1.1. So if I look at R3's routing table and I do a show IP BGP, it's saying that I'm learning 1.1.1 through both R1 and R2. So basically it's saying I'm learning 1.1.1 through this direct BGP neighbor here, and I'm also learning it through the next hop of 24.2, which is this guy, right? So this is the preferred path, right? 10.10.13.1, because BGP prefers their external BGP route versus going through the internal BGP route to get to 1.1.1. So I would rather have this direct connection here because it's external. The admin distance is 20, whereas over here, although I can learn the route this way, it's not the best path, right? Because this is the internal BGP process here, so that's going to take a larger administrative distance of 200. So that's why this is preferred, going through this route. Same thing for learning 2.2.2, right? So for 2.2.2, I'm also preferring going through this route versus this route here through R4 and then R2. Even though I know how to get to R 2.2.2 through R4 and then R2. I'm actually preferring the path of going to R1 to get to 2.2.2. So that's how R3 learns about uh, its AS 5100, 6500 loopback addresses. So let's take a look at R4. How does R4 learn its 1.1.1 and 2.2.2? Well, similarly to R3, it prefers the eBGP path over the iBGP path. So I'm going to learn 2.2.2 through my 10.10.24.2 connection. I'm going to learn 1.1.1 on R4 going through my 10.10.24.2 connection to get to 1.1.1. I'm not going to go this way. I'm not going to go this way because I prefer my external route. So let's take a look. Show IP BGP. Here's 1.1.1. And even though I know how to get there from 13.1 going through R3 to R1, my preferred path is going through 24.2, which is R2. Same thing for 2.2.2, which is going through R2 to learn 2.2.2. All right, so now what I want to do is let's change this. Let's say we want to learn 1.1.1 and 2.2.2. Okay, so we're on R3. We want to learn the 1.1 and the 2.2 address on R3 going through using the R4 path, right? So instead of this is the preferred path right here, we want to choose from R3 to R4 to R2. So we want to use the iBGP route. So this here, we need to change this so that this next hop is preferred. So that this next hop is preferred through 24.2. Okay, so let's do that. So how do we do that? We can use wait as the path manipulation BGP attribute. It's a Cisco proprietary path attribute to influence traffic. So what I'm going to do is I'm going to say whatever route I'm learning from R4, I'm going to give that a weight of 100 to prefer going through R4 to get to my 1.1 and 2.2 address. So this is what I'm going to do. So on R3, I'll simply go config T router BGP 65.200 address family IPv4, and then I will say neighbor 10.234.4 10.234.4 weight 100. Okay, and then from there I can do clear IP BGP star soft reconfiguration. And now if I take a look at my BGP routing table, so before I'm learning it through R1, right? I'm learning it through R1 to get to the loopback addresses here. But I just influenced my route saying that I prefer to go through R4. I'm giving it the weight of 100. So let's see if we can do a show IP BGP. And now we are saying, okay, I'm getting to the 1.1.1 loopback through R4 and then to R2. Same thing for 2.2.2 address. I'm not preferring the R1 anymore. I'm preferring my internal BGP path because I've said that any route that I'm learning from R4, that is the preferred route because I gave it a weight of 100. So we can actually do a test here. Trace 1.1.1.1 to trace 1.1.1.1. So I'm going through 234.4, 10.10.24.2, which is this guy, and then I'm getting to my 1.1.1 that way. Same thing for 2.2.2. All right. And on R4, we already know that we have the preferred path using its eBGP route. So that's how you do the path manipulation using weight. Another way to do that is you can do a route map. So let's go back to R3, and basically we can say, let's get rid of this. No neighbor. Okay, clear IP BGP star soft. Show IP BGP, and we should be back to normal, learning 1.1.1 and 2.2.2 through R1. Best path right there through R1. Okay, let's do the same thing with the weight, preferring to go through R4 to learn R1 and R2's loopback, but let's use the route map statement. So I'll configure my route map. I'll call it weight. Okay, and then I'll just hit enter. This is a nice and easy, simple configuration. And then I can say set weight of 100. That's it. Now, show route map. So I got a route map called weight. My set clause is set to 100 for the metric value. And then now I can go into my BGP routing process. BGP 65200. And I can say address family IPv4. And then neighbor, I'll apply it to R4. I'll say neighbor 10.200.34.4 route map weight in. Alright, END, clear that, clear IP BGP star soft. Now show IP BGP. Show IP BGP, and there it is. You can see that now I am learning the 1.1.1 address and the 2.2.2 address through the R4 path. Boom, boom, boom. Versus this is the original, and this is now the path because we applied the route map statement. All right, so let's go ahead and get rid of that. Um, no route map. Wait. And then router BGP 65200. Address IPv4. And then no neighbor. Let's see if I can just hit the up arrow here. Control A. Alright. Clear IP BGP star soft. Things should return back to normal. Let's give it a few seconds here. Alright, I'm back to normal. I'm learning my 1.1.1 and 2.2.2 in my neighboring AS through my eBGP neighbor. So that's good. Okay. And same with R4. R4 should learn R2 and R1 through its eBGP neighbor as well, which is this guy, and also which is this guy. So that's good to go there. Now, another thing we can do is we can use local preference to also manipulate route. So in this case, let's take a look at R5 here. So how am I learning R1's loopback and R2's loopback using when I'm in R5? So show IP BGP. So here I'm learning R1's loopback by going through R3. I'm learning R2's loopback by also going through R3. All right, so but I actually want to configure my BGP so that I have R5 to prefer learning R1 and R2 through R4. So I want it. So right now we have everything going this way, right? R5, R3, R1 to get to AS 65100. I want to learn routes in AS 65100 through this path here, R5, R4, and R2. So I'm going to set my local preference to say that the path between my ASs of R4 and R2 is preferred over this path between R3 and R1. So the local preference is going to allow me to tell BGP to prefer my path through my external BGP neighbor by setting my local preference of a specific value, right? Because the default is 100. Local preference default value is 100. So anything higher than that is going to be good. So I'll just say 200. So in order to do this, I have to configure. So unlike wait BGP, where I configured my router, my metric using my iBGP neighbor, for local preference, I need to set my local preference metric with the eBGP neighbor. So I'm going to do this on R4. So on R4, I'm going to say config T router BGP. So let's take a look right now. What do we have for R4? Now remember, the ultimate goal is to have R5 learn R1 R2's loopback through this path. Right now it's learning it through this path, but we want to manipulate it so we can go through this path. And also R3 is learning it through this path. We want to manipulate it so that R3 can go through this path. So with local preference, this BGP path attribute feature is going to affect all of the routers in the same AS. So R5 is going to see the same local preference value, R4 is going to see the same local preference value, and R3 is going to see the same local preference value once I set that. So let's go ahead and take a look at R4. Show IP BGP. So R4 is learning R4 is learning 1.1 through R2, but it also can learn it through R1, right? So we're going to configure this so that R4 is only going to learn it through R2. So here we go. So config T, BGP router BGP 65200 is my local AS, right? And then for this, you can set it locally and globally. BGP default, local preference, let's say 600. Boom. All right. Do clear IP BGP. Clear IP BGP star soft. All right. So what I'm saying, what I'm doing with this global command is that I'm telling R4 to set its local preference to 600. So whatever routes that I'm learning, if I'm learning 1.1.1, I before I can learn it through R3/R1 or R4/R2, but now I'm telling it to only go through R4 and R2 path. So there it is. I'm telling it to now only learn routes in AS 6500 through my external BGP neighbor of R2. See that right there? And also 10.100.12.0, which is the link between R1 and R2. How am I learning that? I'm learning it through R2. All right, let's take a look at R3. So this was the before I applied the local preference on R4. R3 learned the loopback of AS 65100 through its eBGP neighbor. But now that I've already configured R4 to tell any router in AS 65200 to prefer my router 4's eBGP neighbor, we should see the 24.2 as the path here. So if I hit the up arrow key, there it is. This is the best path because my local preference is being applied here. I'm preferring R4 as the exiting point for all my local routers in my AS 65200. Same thing here, 10.10.24.2. And how am I learning the 10.100.12? 10.100.12. It's not in here. Okay, I don't think I added that route in here. How is router 5 learning its loopback AS 6500s. How is R5 learning it? Okay, so this was before where it was preferring R3 as its path. Let's go ahead and hit the up arrow key. And so as you can see, even though I didn't configure anything on R5, R5 is also affected here because local preference is also shown here of 600. So any router in the same autonomous system as the router that I configure the local preference, it too will see the applied local preference metric value. So now I'm learning loopback 1.1.1, loopback address 2.2.2.2 through R2. See that? And this is through R2 also. So that's how you can configure that. Let's go ahead and remove this. And if we can say no, and let's do it by the route map command. Do clear IP BGP star soft. Clear IP BGP star soft. Alright, and so now let's go ahead and take a look at the routes. Okay, we should be back to normal. Okay, R3 is learning it through its eBGP peer, which is how it should be, and R5 should be prefer R3 as well. Okay, so we are back to normal. Let's go ahead and configure local preference using a route map statement. So this is pretty easy on R4. So we'll say config T route map local pref set. Let's call local preference of 700 this time. Set local preference 700. Boom. Okay, so now on R4 we can say config T router BGP 65200 is my local AS for R4. Address family IPv4. Now I apply it to my neighbor, my eBGP neighbor. So I can say neighbor 10.10.24.2. I'm applying it to this guy because I want this path to be influenced. Neighbor 10.10.24.2 route map local pref in. All right. So R2 is going to, I'm applying it inbound to R2. So let's take a look. Show IP BGP. Okay. How about R3? Show IP BGP. I think I got to do a clear route. Clear process, clear IP BGP star soft configuration, and let's see if that updates it now. There it is. Local preference before was default, and now it is 700 for 1.1.1 2.2 network. I'm learning it through R4 to R2. I'm learning it through this path here. And the same should be for R5. I should learn it also. You should see local preference of 700 applied to any routes in AS 65100. Well, there it is, and that's how you configure the local preference using the route map. All right, that looks good. So there you go. Two ways to influence traffic using weight and local preference on your BGP router. And weight is basically you apply the weight to your directly connected neighbor, and in the same AS. And for local preference, if you want to use the route map, you apply it to your eBGP neighbor. All right.